What if I told you there's a frozen frontier in our solar system, far beyond Neptune, where millions of icy bodies quietly orbit our sun? Imagine a place, an expanse so vast it makes our blue planet seem like a mere speck of dust. This is not the stuff of science fiction, but a real place within the confines of our solar system. We call it the Kuiper Belt. Nestled beyond Neptune's orbit, the Kuiper Belt is a massive disc-shaped region of space, home to innumerable small bodies composed of rock and ice. It's an extraordinary realm, a silent ballet of icy bodies, each performing a slow dance around our sun. This celestial dance floor stretches from Neptune's orbit, some 30 astronomical units from the sun, to a staggering 50 astronomical units out. To put that into perspective, 1 astronomical unit is the distance from the Earth to the sun. So, we're talking about a realm that's 50 times further from the sun than our Earth is. These icy bodies, the inhabitants of the Kuiper Belt, are remnants from the early solar system, frozen in time and preserved in the cold depths of space. They're like time capsules, each one holding secrets about the early days of our solar system. Their composition of rock and ice tells a tale of the primordial mix from which the planets were formed billions of years ago. But what makes the Kuiper Belt truly fascinating is not just its vastness or its icy inhabitants, but its sheer mystery. It's a place that challenges our understanding of the solar system, a place that continues to surprise us with its secrets and discoveries. And yet, despite its distance and mystery, we have managed to send our probes into this frozen frontier, unlocking some of its secrets and intriguing us with its mysteries. It's a testament to human curiosity and our relentless pursuit of knowledge. So, how did we come to discover this frigid, distant realm? The story of the Kuiper Belt's discovery is one of patience and technological advancement. In the early 20th century, astronomers began to theorize about the existence of a region beyond Neptune, brimming with icy bodies. This was partly due to the peculiar orbits of Uranus and Neptune, which hinted at the gravitational pull of more distant, unseen objects. Among these astronomers was Frederick C. Leonard, who in the 1930s suggested the presence of small planets beyond Neptune. Following suit, Kenneth Edgeworth proposed that the outer solar system was not void as believed, but dotted with numerous small bodies, too far and faint to be detected with the technology of the time. However, the concept of the Kuiper Belt as we know it today was first seriously considered by Gerard Kuiper in the 1950s. Kuiper hypothesized that a disk of icy bodies should exist beyond Neptune, a remnant from the early solar system. Yet it was not named after him until much later. The story then leaps forward to the late 20th century. With the dawn of more sophisticated telescopes and digital imaging technology, astronomers were finally equipped to peer into the dark edges of our solar system. It was in the year 1992 that the efforts bore fruit. Astronomers David Jewett and Jane Liu, using the University of Hawaii's 2.2-meter telescope, discovered an icy body beyond the orbit of Neptune. This object, named 1992 QB1, was the first confirmed resident of the Kuiper Belt. Following this discovery, more and more of these icy bodies were found lurking in the outer solar system, proving the existence of the Kuiper Belt. Each discovery added a piece to the cosmic puzzle, helping us understand the formation and evolution of our solar system. The Kuiper Belt, once a theoretical concept, had become a tangible reality. This breakthrough not only confirmed the predictions of Leonard, Edgeworth and Kuiper, but also opened a new window into the distant past, providing a glimpse of the primordial materials that led to the formation of the planets. With the discovery of these icy bodies, a new chapter in our understanding of the solar system was written. The Kuiper Belt is not a desolate wasteland. It is home to a myriad of celestial bodies, each with its own story. Nestled in this icy realm are a variety of objects known as Kuiper Belt objects, or KBOs. These are a diverse group of bodies that orbit our sun, much like the planets, but at a much greater distance. They are remnants from the early solar system, preserved in a deep freeze far from the warmth of the sun. Among these KBOs are a subcategory called Plutoids. Named after the most famous KBO, Pluto, Plutoids are KBOs that are large enough to have become spherical due to their own gravity. This group includes the likes of Haumea, Makemake, and Eris, each unique in their own right. Pluto, once known as the 9th planet of our solar system, is perhaps the most well-known resident of the Kuiper belt. Despite being demoted to a dwarf planet, Pluto remains a fascinating world with its 5 moons and a heart-shaped glacier. Haumea, on the other hand, is known for its peculiar shape. This elongated object rotates incredibly quickly, causing it to stretch out and resemble a rugby ball. Makemake, named after the creation deity of the Rapa Nui people of Easter Island, is another Plutoid. It is the second brightest object in the Kuiper belt, only outshone by Pluto. And then there's Eris, named after the Greek goddess of discord and strife. Eris is notable for being more massive than Pluto, a fact that played a key role in the redefinition of what constitutes a planet and led to Pluto's demotion. Yet the Kuiper belt is not just home to KBOs and Plutoids. It's also the birthplace of many comets. These icy bodies embark on epic journeys from the Kuiper belt to the inner solar system, putting on spectacular shows as they approach the sun, and their icy bodies vaporize to create glowing comas and tails. These celestial bodies, frozen in time, provide a snapshot of the early solar system. The Kuiper belt continues to be a hotbed of discovery and exploration. Even as we speak, scientists are uncovering new insights about this distant frontier of our solar system. One of the most groundbreaking recent discoveries was made by NASA's New Horizons mission. In 2019, this intrepid spacecraft performed a flyby of the Kuiper belt object, or KBO, known as Arakoth. This celestial body, previously known only as Ultima Thule, was revealed to be a contact binary, a single entity formed from 2 separate bodies in close contact. This discovery has provided invaluable insights into the process of planet formation and the early history of our solar system. But the exploration of the Kuiper belt doesn't stop with New Horizons. Today, astronomers continue to study this region using powerful ground and space-based telescopes. By observing the light reflected off these distant objects, they can determine their composition, size, and other physical characteristics. These observations are helping to refine our understanding of the Kuiper belt and its role in the solar system's evolution. Looking ahead, the future of Kuiper belt exploration is bright. NASA and other space agencies around the world have a number of ambitious missions in the works. These missions aim to send spacecraft to the Kuiper belt to study its inhabitants up close and personal. They will look for signs of water, organic molecules, and other ingredients necessary for life as we know it. Who knows what surprises these far-flung worlds have in store for us? But it's not just about scientific discovery. The Kuiper belt also holds potential for future human exploration and even colonization. The resources found on these icy bodies could be used to support human life and fuel space travel, opening up new possibilities for our species. The Kuiper belt, once a mere speculation, now stands as a testament to our ever-growing curiosity and our relentless quest for understanding our cosmic neighborhood. As we continue to push the boundaries of our knowledge and capabilities, who can say what mysteries we will unravel next? In the span of just a few decades, the Kuiper belt has transformed from an astronomical theory to a fascinating reality. Let us take a moment to reflect on our journey into the depths of our solar system, beyond the 8th planet, Neptune. We've ventured into the realm of the Kuiper belt, a mysterious and icy region, home to countless celestial bodies. A place where frozen volatiles like methane, ammonia, and water exist, giving us a glimpse into the primordial conditions that led to the formation of our solar system. We've traced the history of its discovery, a remarkable tale of scientific intuition, persistence, and technological advancement. It was theorized in the early 20th century, but it wasn't until the 1990s that its existence was confirmed. Now, it stands as a testament to our collective curiosity and our unquenchable thirst to explore the unknown. We've met the inhabitants of the Kuiper belt, a diverse collection of objects from dwarf planets like Pluto and Eris to smaller, icy bodies. Each one unique, each one contributing to the larger narrative of our cosmic neighborhood. And let us not forget the recent discoveries and future explorations. With every new mission, every new observation, we peel back a layer of mystery surrounding the Kuiper belt. We've seen New Horizons' close encounter with Pluto and the distant object Arakoth, revealing details that were once beyond our reach. As we stand on the edge of this icy frontier, we can't help but wonder about the vastness of our universe and our place within it. The Kuiper belt is not just a distant region of space. It's a time capsule, a cosmic laboratory, a place of endless possibilities. As we continue to explore this icy frontier, who knows what mysteries we might uncover next? The Kuiper belt, a testament to the wonders of our solar system, continues to captivate and challenge us, reminding us that the universe is far more vast and complex than we could ever imagine.